Another day, another story. Is time travel possible? Scientists and science fiction writers alike continue to imagine the possibilities. Short answer: yes, and you're doing it right now, hurtling into the future at the impressive rate of 1 second per second. You're pretty much always moving through time at the same speed. But this isn't the kind of time travel that's captivated countless science fiction writers, or spurred a genre so extensive that Wikipedia lists over 400 titles in the category, movies about time travel. In franchises like Doctor Who, Star Trek, and Back to the Future, characters climb into some wild vehicle to blast into the past or spin into the future. Once the characters have traveled through time, they grapple with what happens if you change the past or present based on information from the future, which is where time travel stories intersect with the idea of parallel universes or alternate timelines. Although many people are fascinated by the idea of changing the past or seeing the future before it's due, no person has ever demonstrated the kind of back-and-forth time travel seen in science fiction or proposed a method of sending a person through significant periods of time that wouldn't destroy them on the way. And, as physicist Stephen Hawking pointed out in his book, Black Holes and Baby Universes, Bantam, 1994, the best evidence we have that time travel is not possible, and never will be, is that we have not been invaded by hordes of tourists from the future. Science does support some amount of time bending, though. For example, physicist Albert Einstein's theory of special relativity proposes that time is an illusion that moves relative to an observer. An observer traveling near the speed of light will experience time, with all its aftereffects, boredom, aging, etc., much more slowly than an observer at rest. That's why astronaut Scott Kelly aged ever so slightly less over the course of a year in orbit than his twin brother who stayed here on Earth. There are other scientific theories about time travel, including some weird physics that arise around wormholes, black holes, and string theory. For the most part, though, time travel remains the domain of an ever-growing array of science fiction books, movies, television shows, comics, video games, and more. Special relativity and time travel to the near future. Twin brothers Scott and Mark Kelly are both astronauts, and have both participated in landmark studies about the effects of space on the human body. Einstein developed his theory of special relativity in 1905. Along with his later expansion, the theory of general relativity, it has become one of the foundational tenets of modern physics. Special relativity describes the relationship between space and time for objects moving at constant speeds in a straight line. The short version of the theory is deceptively simple. First, all things are measured in relation to something else. That is to say, there is no absolute frame of reference. Second, the speed of light is constant. It stays the same no matter what, and no matter where it's measured from. And third, nothing can go faster than the speed of light. From those simple tenets unfolds actual, real-life time travel. An observer traveling at high velocity will experience time at a slower rate than an observer who isn't speeding through space. General relativity and GPS time travel. The Global Positioning System, or GPS, helps us know exactly where we are by communicating with a network of a few dozen satellites positioned in a high Earth orbit. The satellites circle the planet from 12,500 miles, 20,100 kilometers, away, moving at 8,700 miles per hour, 14,000 kilometers per hour. According to special relativity, the faster an object moves relative to another object, the slower that first object experiences time. For GPS satellites with atomic clocks, this effect cuts 7 microseconds, or 7 millionths of a second, off each day, according to the American Physical Society publication Physics Central. Then, according to general relativity, clocks closer to the center of a large gravitational mass like Earth tick more slowly than those farther away. So, because the GPS satellites are much farther from the center of Earth compared to clocks on the surface, Physics Central added, that adds another 45 microseconds onto the GPS satellite clocks each day. Combined with the negative 7 microseconds from the special relativity calculation, the net result is an added 38 microseconds. This means that in order to maintain the accuracy needed to pinpoint your car or phone, or, since the system is run by the U.S. Department of Defense, a military drone, engineers must account for an extra 38 microseconds in each satellite's day. The atomic clocks on board don't tick over to the next day until they have run 38 microseconds longer than comparable clocks on Earth. Given those numbers, it would take more than 7 years for the atomic clock in a GPS satellite to unsync itself from an Earth clock by more than a blink of an eye. We did the math. If you estimate a blink to last at least 100,000 microseconds, as the Harvard Database of Useful Biological Numbers does, it would take thousands of days for those 38 microsecond shifts to add up. This kind of time travel may seem as negligible as the Kelly brothers' age gap, but given the hyper-accuracy of modern GPS technology, it actually does matter. If it can communicate with the satellites whizzing overhead, your phone can nail down your location in space and time with incredible accuracy. Can wormholes take us back in time? General relativity might also provide scenarios that could allow travelers to go back in time, according to NASA. But the physical reality of those time travel methods is no piece of cake. Wormholes are theoretical tunnels through the fabric of space-time that could connect different moments or locations in reality to others. Also known as Einstein-Rosen bridges or white holes, as opposed to black holes, speculation about wormholes abounds. But despite taking up a lot of space, or space-time, in science fiction, no wormholes of any kind have been identified in real life. Primordial wormholes are predicted to be just 10 to the power of 34 inches, 10 to the power of 33 centimeters, at the tunnel's mouth. Previously, they were expected to be too unstable for anything to be able to travel through them. However, a study claims that this is not the case, Live Science reported. The theory, which suggests that wormholes could work as viable spacetime shortcuts, was described by physicist Pascal Coiron. As part of the study, Coiron used the Eddington-Finkelstein metric, as opposed to the Schwarzschild metric which has been used in the majority of previous analyses. In the past, the path of a particle could not be traced through a hypothetical wormhole. However, using the Eddington-Finkelstein metric, the physicist was able to achieve travel theories. While Einstein's theories appear to make time travel difficult, some researchers have proposed other solutions that could allow jumps back and forth in time. These alternate theories share one major flaw. As far as scientists can tell, there's no way a person could survive the kind of gravitational pulling and pushing that each solution requires. Infinite cylinder theory. Astronomer Frank Tipler proposed a mechanism, sometimes known as a Tipler cylinder, where one could take matter that is 10 times the Sun's mass, then roll it into a very long, but very dense cylinder. The Anderson Institute, a time travel research organization, described the cylinder as a black hole that has passed through a spaghetti factory. After spinning this black hole spaghetti a few billion revolutions per minute, a spaceship nearby, following a very precise spiral around the cylinder, could travel backward in time on a closed, time-like curve, according to the Anderson Institute. The major problem is that in order for the Tipler cylinder to become reality, the cylinder would need to be infinitely long or be made of some unknown kind of matter. At least for the foreseeable future, endless interstellar pasta is beyond our reach. Time donuts. Theoretical physicist Amos Ori at the Technion Israel Institute of Technology in Haifa, Israel, proposed a model for a time machine made out of curved space-time, a donut-shaped vacuum surrounded by a sphere of normal matter. If we were to create an area with a warp like this in space that would enable timelines to close on themselves, it might enable future generations to return to visit our time. There are a few caveats to Ori's time machine. First, visitors to the past wouldn't be able to travel to times earlier than the invention and construction of the time donut. Second, and more importantly, the invention and construction of this machine would depend on our ability to manipulate gravitational fields at will, a feat that may be theoretically possible but is certainly beyond our immediate reach. Time travel in science fiction. Time travel has long occupied a significant place in fiction. Since as early as the Mahabharata, an ancient Sanskrit epic poem compiled around 400 BC, humans have dreamed of warping time. Lisa Yashek, a professor of science fiction studies at the Georgia Institute of Technology in Atlanta, told Live Science. Every work of time travel fiction creates its own version of space-time, glossing over one or more scientific hurdles and paradoxes to achieve its plot requirements. Some make a nod to research in physics, like Interstellar, a 2014 film directed by Christopher Nolan. In the movie, a character played by Matthew McConaughey spends a few hours on a planet orbiting a supermassive black hole. But because of time dilation, observers on Earth experience those hours as a matter of decades. Others take a more whimsical approach, like the Doctor Who television series. The series features the Doctor, an extraterrestrial Time Lord, who travels in a spaceship resembling a blue British police box. People assume, the Doctor explained in the show, that time is a strict progression from cause to effect, but actually from a non-linear, non-subjective viewpoint, it's more like a big ball of wibbly-wobbly, timey-wimey stuff. Long-standing franchises like the Star Trek movies and television series, as well as comic universes like DC and Marvel Comics, revisit the idea of time travel over and over. Thanks for watching.